This is your NAT topology. You have some computers in your LAN environment, LAN PC. This is connected to your routers. A router is connected to internet provider. Okay, here you will have a public IP. This would be public IP. This would be private network. This would be a private IP. Okay. So whenever you do NAT, there are things which we call it a inside local. Okay. Then inside global. This the term inside means our local IP addresses or it belongs to our company. Whenever you see the inside, it is the limitations till a company. It will not be outside the world, it will be our inside world. So when you say inside local, that would be your private IP address, your PC or private IP addresses, or PC IP you can say, or LAN user IP. Suppose this is 192.168, 1.1 or 1.10. This would be inside local in the NAT terminology. Then we will have one public IP, right? This would be, suppose the public IP is 100.1.1.1. This would be our inside global. Okay, whenever we use show IP NAT translations and we check which IP translated with which IP, then you will see like inside local would be your private IP, inside global would be your public IP, the customer environment public IP. Then there would be outside local and outside global. This would be belongs to something we call it like Google server. We are accessing Google, assume. This outside local and outside global, most of the times when you do source NAT, that outside local and outside global would be same IP, that would be public IP of a google.com or something. Assume, yeah, how we checked yesterday, we checked like IP address finder. I type like google.com. Let us see. This is not IP finder. Okay, hold on. So this is IP of google.com, right? So this is a destination where we are accessing. See google.com, latitude, longitude, and everything. We got IP address is this one. So in our term, the Google IP is, this is a Google IP. So this would be whenever we suppose in a real time environment, when I do natting from a source and my source is trying to access google.com. Okay, this particular source is trying to access google.com. Then on a router, whenever you see NAT translations, okay, you will see like inside local would be PC private IP, inside global would be your router public IP, then outside local and outside global, this would be Google public IP. This all would be Google public IP. Okay, let us see how we can check it in our router. Let me do one ping from a router, then you will understand. As of now, do we have any NAT translations? Please show IP NAT translation. We do not have any NAT translation because there is no traffic initiated from long time. Not 1.2.10. Let us see. Request timeout. Show IP interface brief. Okay. Now we are getting replies. Okay. Now let me see again. Show IP NAT translations. Sorry. Now you see we have inside global, that is our private public IP 100.1.1.1, right? Then we have inside local, that is our PC IP. Then outside local and outside global would be same IP when we do source NAT, because there is no different IP. We are trying to access one particular IP and there is no NAT happening on this particular thing. Okay. So outside global is this IP and outside local also this IP 10.1 100.1.2.10. This is the IP we are trying to reach, right? So if you take it in a table format, our source is PC, then destination, this another PC, PC1, source was PC0. Then what is a inside global? PC0 is a inside local. Then destination PC1 is a outside local, outside global, same. Or else let me do one thing. This will confuse you again. As per our understanding, see, inside local, inside global, outside local. These are the four things you will see in a router, right? If you see inside global, inside local, outside global, right? So in a inside local, what we are saying, PC private IP, right? Inside local means so PC private IP from where we are initiating a traffic. If you see IP config, this is a private IP of a PC, right? And same thing I am able to see on my inside local. Then inside global, router WAN IP. So that's what we are able to see. If you check a show IP interface brief 100.1.1.1, right? So I am able to see 100.1.1.1 in a inside global. Then outside local, destination public IP. Outside global also destination public IP. That's what this particular IPs are usually same when we are doing, when we are accessing a internet or something on our environment. Okay, you see outside local and outside global is same. This would be different when you are doing a destination NAT or something, but in our case this would be same. Where there would be a difference you will learn in your CCNP when you are doing advanced NATing or something. Okay, but as for now, if you understand terminologies, what is inside global, what is inside local, what is outside local, what is outside global, that would be fair enough for you. And this can be your interview question also, so you need to understand this particular terminologies. Okay, is it clear?
Yes, sir.
Yeah. And there are two things when you do NAT, it can come in your interview. Which interface would be NAT inside and which interface would be NAT outside. So if you check our configuration, show running config, see wherever we have private IP, our LAN interface, that is our NAT inside, and where we have our WAN interface, which is a public IP or connecting to outside world, that is our IP NAT outside. See in our topology, the interface which is connecting to LAN side, that is NAT inside. The interface which is connecting to WAN side, there we will configure NAT outside. Okay, you need to remember these things. Mostly no one will ask you commands in an interview. If you understand concept, that would be enough. Okay, so that is enough for an NAT for CCNA. Now we have things like DHCP, then DNS. What is a DHCP now? Dynamic host configuration. See, till now when we have a PC or something, suppose I have one computer. This is my PC. This PC need one IP address now, right? Till now we were giving IP address manually, but in the real time environment, I can have 100 computers or I can have 1000 computers, and it can be unlimited, right? And every user I need to go and manually configure IP address. It would be a hectic task, and I will not remember which IP I have configured to whose which user, right? It would be very difficult to remember in a real time environment. So to overcome this, there is a protocol, we call it a DHCP. What DHCP will do, we can, instead of configuring manual IP on a PC, we can ask a PC to take IP address from DHCP. Then DHCP sir, there would be one DHCP server. It can be on a router, it can be on a L3 switch, or it can be one dedicated server in an environment. So whoever is running a DHCP services, DHCP server role, they will assign a IP address to a computer. Their particular DHCP role, DHCP server role is to give a IP address to a computer. Then the computer will request IP address, and this would be one request. What computer will ask, please give me IP. Then what server will do, please take this IP and configure it. IPX and configure on your interface. So we don't need to manually configure it. So PC will request to a server, server will send a IP address, and it would be configured automatically on a PC. See, assume now you have a mobile. Your mobile is connected to a Wi-Fi, right? This is a Wi-Fi router in your home. Whenever you connect to a Wi-Fi router, your PC will get one IP address from a Wi-Fi router. A Wi-Fi router is acting as a DHCP server. If you open your mobile, you go to Wi-Fi settings, you will get one IP address which is configured via DHCP. Your PC will be acting, or your mobile will be acting as a DHCP client, and Wi-Fi router would be acting as a DHCP server. Server role is to give a IP address. A client role is to take IP address or to request IP address from a server. Okay. So let us see on my PC what IP I have. My PC is acting as a DHCP client. You see Wi-Fi details. DHCP enable. Yes, I have DHCP enabled, and I got this below IP from a DHCP. Okay. And this is my gateway router. Let me log into this router and I'll show you. 192.168.1.1. Okay. I don't know password, maybe. Data NVYSJ. Let me see if I know. Okay, I got a login. Network LAN. Let us see. You see, enable DHCP server. I have DHCP server enabled. And what is my starting IP? What is my finishing IP? So whenever I have a users or clients connecting to my home Wi-Fi, they will get IP from this range. Okay. Let us see under monitoring which device got what IPs or something. Status user info. Okay. Configured IP addresses. Okay. I have this particular computers. What is my PC IP or something? Please remaining 23 hours and all. Okay. This should be my desktop one thing. Let me see. This PC properties desktop. This is my desktop name, and that should be my IP address, right? What is 1.4 is my IP. So I got a IP address from a DHCP server, and it has a lease remaining 23 hours. So what is a lease? I'll tell you. So that's how one particular device would be acting as a DHCP client. Whoever wants a IP address, because he wants IP, right? Your mobile or your laptop wants a IP address, and a server would be acting as a DHCP server to provide IP address to one particular machine. Then in a DHCP there would be a process, we call it a DORA. This would be an important part in your interview. What is the DORA process? They can ask you. So DORA means in a D it is a discovery. A PC will send one message. It would be broadcast message, which is a discovery message. It will try to find the DHCP server. Okay. Then O means offer. DHCP server will send a offer that I am a DHCP server. Okay. Then we will have request. R means request. PC will initiate IP request to server. Then A means acknowledgement. Server will send IP with acknowledgement to PC. Okay. This is called a DORA process. Discover, offer, request, acknowledge. Okay. You need to understand this DORA process. It is a theory part you will not see mostly in your lab environment. You can do a packet capture and you can do that, but for your CCNA part, it is a theory part. If you understand what is DORA process or you remember this, that should be more than enough. Okay. So now one more part in a DSCP is lease time. Now assume this mobile requested a IP address, a router gave a IP address. This whatever router gave IP address, it is not permanent IP address. It is given for a particular duration. Duration can be 1 hour, it can be 8 days, anything. Okay, it can be 30 minutes or something also. This particular duration we call it lease time. So after a lease time expires, again a PC need to request IP and router or DHCP server need to give a new IP address. Okay. So now let us configure one DHCP server and let us see. Now where is the router? From a PC I will remove IP address. Under settings I'll tick it as a DHCP. From a fast Ethernet also it would be DHCP now. From a static I'll remove it and I'll configure it as a DHCP. Now if you see what is IP config slash release. I am releasing my IP address. Okay. Now let us see IP config. I don't have any IP address as of now. Okay. Now let us go to a router. Show running config. Show running config. Let me delete all this config t no IP DHCP pool my no. Okay. Show running config t no copy and paste. I had one DHCP pool configured some time before, so let us see. Show running config. Do I have anything now? I don't have anything now. Okay, let us see. IP config, nothing is there. Okay, done. Now I will configure one DHCP pool on this router 0. So to configure DHCP pool, IP DHCP pool, whatever name you want to give, you can give, or I will give like LAN pool. Then what is the network address of that pool? Network 192.168.1.0. Then what is the mask of that particular network? 255.255.255.0. Then what would be the default gateway of this pool? IP default router 192.168.1.1. So users will get this particular IP as a default gateway. Okay, and p pool. This is my pool subnet in the current pool. IP address range. Okay, I don't have any list given as of now. So now let us go to PC. Sorry, I'll go to one. Remove this. Okay, let me go to PC again. Then we will see IP config slash renew. I will do. Then we will see IP config. I got one IP 1.2. Then gateway I did not get anything. Let us see config fast ethernet 0/0. Okay, now let me go to again. I'll do config release, config renew. We will see what we will get. See, if you have already IP address on a PC, what you can do, IP config slash release. This will release the IP address and slash renew. This will request a new IP address. Now we got one IP address. Then what is a subnet mask and what is the default gateway of that IP address. Now let us see. I got IP address from settings, default gateway, DHCP, fast ethernet. Okay. Okay. Now let me go to a router again and let me see. Previously there was no leased, right? Now I got one leased. So show IP DHCP. In this router we cannot check which IP given to whom. 1 minute. What is the pool name? We have LAN pool. Okay. That's all we will get. So now let me add one more I cannot add another PC. Let me add one switch, then I can add a couple of PCs more. So what I can do, under a switch, I will have one switch here. This I will remove and I will connect to switch. From a switch, I will take one more cable and connect to a router. In this way, I can add more PCs now. I will add one more PC here. I will add it and I will give it this. Okay. Let me do a fast forward. As of now, we have not done anything. By default, the PC would be in a DHCP mode. It should be. So we will do it in real time. It should be in a DHCP mode. Okay. Now we got 1.3 IP. IP config. We got 1.3 IP. Slash all. And IP address, how we received. Let us see. DHCP server also we have received. Okay. Now let us see on a router. Did we get another IP or not? Show IP DHCP LAN pool. Now you see we have two leased, right? Two into two particular devices, two particular IPs. This server has provided two IPs, two particular users. So IP DHCP binding. Okay. Now we received 1.2 is given to this particular user. 1.3 is given to this particular user. So what is IP of MAC address of this PC? Let us see. 79B3. This PC MAC address is, you see it is MAC address 79B3, right? You see here. I cannot hold that. Under fast Ethernet uplink IP address, then MAC address 79B3 we got. Then what is the MAC address of this? 8BB6. 8BB6 received what IP? 8BB6 received 1.3, right? That's how you can check what is the particular which user got what IP and how many users. Even you can have 100 users to same particular switch. Then 100 users can get a IP address from a router itself. You don't need to go to a PC and configure a router manually. Okay. Is it clear? How can you use a DHCP in your environment? Hello.
Yes, sir.
Okay. So now there is one more thing in a DHCP, IP excluded address. So now suppose I have my DHCP pool is 192.168.1.0/255.255.255.0, right? So in this, how many IP addresses I am getting? 254, right? 192.168.1.12, 192.168.1.254. So I am getting 254 IP addresses, right? Correct? In this pool, I am getting this many IP addresses. Is it correct?
Yes.
I don't want this many IP addresses. I want to exclude some IP addresses given to clients. I don't want like 192.168.1.12, 192.168.1.10. These IP addresses should not be given to anyone. This should be reserved for future or some different purpose. This should be reserved and this should be not be given to anyone over DHCP. Okay. So now let us see how we can do. Config T IP DHCP excluded address. Then I can write what is the starting address. Lower IP 192.168.1.1. What is the highest IP? 192.168.1.10. So these IP addresses will not be given to anyone now. Now let us go to PC again. I'll go to desktop. I'll do it like ipconfig/release. Then I will do it like ipconfig/renew. Let us see. Now you see I did not get 1.2. I got 1.11. Similar to that, I'll go to PC3 also. It has 1.3 previously. ipconfig slash release. I am releasing whatever IP I had. Then I will renew IP address. So I will get new IP address from a DHCP server. See, I got 1.2 well. Now let us go to a DHCP server. We will do like IP DHCP pool, LAN pool. I got two leased addresses. One is excluded. One particular pool is excluded. Show IP DHCP binding. Now I got 1.11 and 1.2 well. I did not get 1.2 or 1.3. Previously we were getting 1.2 and 1.3, right? So that's how you can do DHCP configuration. Now one more thing is DNS. So DNS would be used for domain name services. I want you to work on yourself and check why do we need a DNS, how DNS works. Then we will continue tomorrow with the DNS. Okay. For today's class, this should be enough.